Okay. Good day, everyone. We are now on our seventh lesson in differential calculus. So ngayon, ang di-discuss naman natin is the chain rule. Yung concept ng mga present ko, ng mga nakaraan, uh, mga basics sila. No? Um, Polynomials, derivative na derivative ng polynomials, derivative ng mga trigonometric functions. Itong chain rule, yung ipe-present ko dito, ito talaga yung pinaka fulcrum ng any introductory calculus course. So, napaka-importante na ma-master ninyo ang chain rule para makapag-solve kayo ng mga mas advanced na mga functions. Kasi kung mapapansin ninyo, doon sa mga binibigay kong examples sa mga previous videos natin or previous lessons natin, direct substitution ng mga formulas. But now, pag gumamit tayo ng chain rule, we are now dealing with significantly more advanced functions. Okay? So kung wala ang chain rule, ano yan para lang tayong, uh, kumbaga nagro-road trip tayo gamit tricycle. Okay? So, napakahirap dahil iisa-isahin natin yung paggamit ng y plus delta y tapos pagkapalit ng x plus delta x. So itong chain rule, it will be used to develop yung mga mas advanced na ideas sa calculus. And itong chain rule na to is a critical concept sa buong study natin ng calculus. Kaya naman pag-igihan natin, makinig tayo mabuti at mag-take tayo ng notes. At the same time, mag-solve tayo ng mas maraming problems dito sa chain rule para mas makapag-practice tayo at ma-master natin itong concept na ito. Alright? So before I proceed to the derivatives ng mga composite functions, let us have a quick recap lang ng ating mga formulas, no? Ano na ba yung mga na-discuss natin na mga derivatives? Tapos mamaya babalikan natin 'yan after natin mag-discuss ng chain rule, babalikan natin yung yung mga formulas na ito at ano ba ang nabago. Okay? Now, so ang unang diniscuss natin is yung derivative ng constant, right? So ang derivative ng constant, sulat lang natin dito, the derivative ng constant, so let's say with respect to x, So, ulit. Derivative with respect to x ng constant value or number ay equal yan sa 0. Okay? Tapos, diniscuss din natin yung sum, right? So, yung derivative ng dalawang function, no? U plus V, di ba? Equal yan sa derivative ng with respect to x, With respect to x ng U plus the derivative with respect to x ng V. So, ibig sabihin distributive ang derivative. Pagdating naman sa product, diniscuss din natin yung sa product, yung derivative ng product ng dalawang functions, uv, equal yan sa first function times the derivative ng second function plus the second function times the derivative ng first. Tapos, diniscuss din natin ang derivative ng mga quotient, right? So, derivative ng quotient ng dalawang function, u over v, equal yan sa denominator times the derivative ng numerator minus the numerator times the derivative of the denominator. All divided by the denominator squared. Okay? So, ganyan lang naman siya. Tapos, diniscuss din natin yung sa mga polynomials, right? So, derivative with respect to x ng x to the n. Di ba? Ang naging sagot natin dyan is, pinababa natin yung n, tapos x to the n minus 1. So, pag x to the n, ganyan yung ginagawa natin, right? Tapos, diniscuss din natin itong radical derivative with respect to x ng square root ng x, di ba? So equal pala yan sa 1 over 2 square root of x. So ano pa yung diniscuss natin? Sa mga trigonometric functions, nag-discuss na rin tayo niyan, tama ba? Ang diniscuss natin sa trigonometric functions, yung derivative with respect to x ng sin x, right? So ito naman, ang sagot natin dito ay cosine ng x. Tapos ang derivative with respect to x ng cosine x ay equals naman sa negative ng sin x. So meron pa yan, derivative with respect to x ng tangent ng x, equal naman yan sa secant squared ng x. Diba? Tapos yung derivative, yung derivative with respect to x ng ano pa maganda? Unahin natin yung cotangent, no? Cotangent ng x equal yan sa negative cosecant squared x. Then ano pa? The derivative with respect to x ng secant x equal yan sa secant x tangent x. So nakamultiply yan, no? Lastly, yung derivative with respect to x ng cosecant x. Equal naman yan sa negative cosecant x cotangent x. So, basically, ito yung mga diniscuss na natin na mga formulas na ginagamit natin sa pagkuha ng mga derivatives ng basic polynomial tsaka mga basic na mga trigonometric functions. Okay? So now, ang nagiging problema natin or magiging problema natin is that paano pag ang kinukuha na natin ng derivative is yung mga composite, no? Mga composite functions. So, perhaps siguro na mas napansin niyo na yung mga sinosolve natin mga simple pa lang, no? For example, ganito yung mga sinosolve natin. Y is equal to cosine x, di ba? So pagka ganyan yung equation, meron tayong formula. Pero paano kung ganito yung binigay sa atin? Y is equal to cosine ng 5x, right? Or let's say 5x plus 3. Paano naman natin yan isa-solve? Dahil wala dyan yung formula, para dito, it will be very hard for us na isolve itong ganitong klase ng function or pagkuha ng derivative ng ganitong klase ng function. And another one, siguro na pwede kong ibigay na example, paano naman yung pagkuha ng derivative ng mga, let's say, radical pero merong power sa loob, x squared plus 5, for example. Wala tayong pwedeng magamit na formula dyan to apply for these particular composite functions, no? Ang reason, kasi mas maraming involvement yung derivatives sa mga composite function. Ibig sabihin, gagamit tayo ng mas maraming pagkuha ng derivative sa mga composite functions. Kumpara dito sa mga basic functions na to, mga in terms of x pa lang sila. Okay? For example, maaring dito sa cosine of 5x plus 3, ang natural guess natin is to find yung ganito, gamitin itong formula na to. So we might guess that the y prime is equal to negative sign, no? Negative sign of 5x plus 3, which is wrong, no? Hindi ganyan ang pag-solve ng ating composite functions. So, kung meron kayong mga calculators na kaya mag-solve ng derivatives, mas maganda. Pero, kailangan intindihin natin yung concept ng chain rule para ma-solve natin yung mga ganitong functions, no? So, iiwanan muna natin itong ating discussion sa recap na yan. So sa ngayon, yan muna yung ating mga formulas na gagamitin. And then, I will introduce the understanding ng notation ng ating chain rule. Okay? So, yung chain rule, okay, ang sabi is that if we have, let's say we have, tawag dito, delta y, let's say we have a function, okay, para mas madali ko ma-explain sa inyo. Let's say we have a function y is equal to the square root of x squared plus 1, right? Apparently, kung wala nga tayong magagamit na formula dyan, galing dito sa mga formulas natin na to. So, napakahirap niya, no? Pero, masasolve pa rin natin to using the chain rule. So, paano ba natin gagawin yon? We are now going to represent itong nandito sa loob, x squared plus 1. Yung expression na yan, papalitan natin ng variable. Okay? So, we are now let uh, let u, okay, u of x, no? This is another function of x na ini-introduce natin para palitan yung ating uh, function sa loob. Okay? So, x squared plus 1. Okay? Kaya ngayon, ang mangyayari dyan, yung ating y will now become y is equal to the square root of u. And in this case, pwede na nating makuha yung kanyang derivative using this formula, di ba? Yung formula na yun yung gagamitin natin. Pero, kailangan maibalik natin yan sa x, right? Kaya naman, pag sinubukan natin itong isolve, ang makukuha kasi natin, dy with respect to u. No? So, ang pinapahanap kasi sa atin dito, what is dy with respect to x? O yung ating y prime. No? So, yun ang pinapahanap sa atin. Kaya lang dito kasi sa equation na to, ang makukuha lang natin dyan, dy du. It is equal to 1 over 2 square root of u. Right? In this case, kulang pa rin yung ating answer kasi dy du yan, right? So kailangan pa natin mahanap yung dx, no? So para makuha natin yung dx, kailangan kukunin natin yung derivative nitong ating representation, no? So pag kinuha natin yung derivative niyan, du with respect to x, it is now equal to 2x plus 0, right? So that is simply 2x. So itong dalawa, dy du tsaka du dx, pwede natin yung pagsamahin to get the right answer. So ang sinasabi sa chain rule is that yung ating okay, delta y, dapat yata hindi dito. Okay. Yung ating delta y divided by delta x can be represented, no, by another function wherein delta y over delta u is multiplied to delta u over delta x. No? So, ibig sabihin, para makuha natin yung delta y, delta x, magre-represent tayo ng isang function, papalitan natin yan ng u, tapos kukunin natin yung derivative ng u na yon with respect to x. Okay? So, pag kinuha natin ang limit na to, limit as delta x approaches 0 ng dy over dx, it will now become equal to the product ng dalawang limit, right? So, limit as delta u approaches 0, right, of delta y over delta u times the limit as delta x approaches 0 ng delta u over delta x. And alam naman natin, ito yung definition ng derivative, dy dx is, ang pangit ng sulat ko. Ulitin natin. dy dx is equal to dy du times du dx. Ano ibig sabihin yan? So, pwede pala tayong gumamit ng function u to replace yung mga uh, x or function ng x sa ating equation, and then balikan natin mamaya. No? So, napaka useful nitong ating chain rule pagka gagamit or magsasolve tayo ng mga mas uh, advanced na functions. Okay, katulad nitong example natin ito. So ngayon, balikan natin yung pag-solve using the chain rule, no? Yan. Using this concept, pwede nating balikan ito, no? So nakuha natin dy du tsaka du dx. We now have y prime equals dy dx, and it is also equal to dy du times du dx. So, gamitin lang natin yung formula natin na yan. That will become 1 over 2 times the square root of u times yung du dx natin is 2x. Okay? So, ngayon, meron pa ring u dyan. Tama ba? So, papalitan lang natin yan ng ating representation. No? U is equal to x squared. Papalit lang ulit natin yan. So, this will now become equal to 1 over 2 times the square root of x squared plus 1. Yan. Times 2x. So in this case, lumalabas na ito yung ating derivative pagka pinalitan na natin ng u, yung ating variable. Tapos kinukuha pa natin yung derivative ng mismong variable, right? So, ganyan yung ating, simplify natin ha. So this will now become x. So mag-cancel yung dalawang 2, x over the square root of x squared plus 1. Plus 1. Okay? So, ganyan siya. No? So, sa pag-aaral natin ng calculus, meron tayong dalawang klase na kung paano yan ginagawa. Okay? So, meron kasing notation, no? Na itong notation na ginagamit ko or in-apply ko sa inyo is yung tinatawag nating Leibniz, no? Leibniz. Okay? So, using Leibniz notation. So, kung paano ko siya sinolve, ganyan siya. Na magpapalit tayo ng u, tapos solve natin yung du dx, tapos gagamitin natin itong particular formula na to. Okay. So, yan yon. Meron din naman na ginagamit yung notation naman na ni Lagrange, no? So, in this case, si Leibniz, ginagamit natin yung dy dx equals dy du times du dx. Ito namang si Lagrange, no? Ginagamit niya yung notation ng prime, no? Although parehas lang din naman sila ng tawag dito, ng principle. Okay? Ang kinaibahan lang natin dito kay Lagrange is ganito siya mag-solve. So let's say we have a function y, it is equal to a function of another function, right? So let's say f of g of x. Ganyan. So ibig sabihin, we have a function inside another function. And pag kinuha daw natin yung y prime neto, no? It will become equal to f prime of g of x, okay? So palitan lang natin ng kulay siguro yan. Okay? F prime of g of x times g prime of x, no? Times 15. Yan. Times g prime of x. So kung gagawin natin yan dito sa ating example, so let's say we have y is equal to the square root of x squared plus 1. So yung ating y prime will be equal to, di ba, 1 over 2 square root of x squared plus 1, di ba? Kasi in-apply ko lang naman yung f prime. In-apply ko lang yung f prime, ito yan. Times yung laman natin, yung g of x natin, dapat yata kulayan ko ng blue. No? Ito yung ating x squared plus 1 times yung ating g prime of x, which is actually times 2x. So kung i-simplify na natin, y prime is equal to x over the square root of x squared plus 1. So ganyan siya, no? Although parehas yung kanilang approach, itong kay Lagrange, it provides an additional perspective uh, dun sa paggamit ng ng rule natin na to, no? Uh, kung meron tayong composite function, ganun nga. Kukunin muna natin yung uh, derivative ng hindi ginagalaw yung function sa loob, tapos i-multiply natin dun sa derivative nung nasa loob. So parang papasok siya ng papasok pagkuha ng derivative, no? Maganda rin itong uh, approach ni Lagrange sa paggamit ng derivative kasi kumbaga kung marami tayong layers ng functions or composite functions, per layer natin sinasolve yung pagkuha ng derivative. Pero uh, I would suggest na maging familiar tayo sa parehas, no, sa Leibniz tsaka sa Lagrange notations kasi ano yan, madalas pwede natin silang gamitin interchangeably sa mga calculus problems, no? Let's try to solve a few example, no? A few examples of applying yung ating chain rule, okay? So, yeah, let's try to apply with this particular example. Um, let's try to solve the derivative for a function y is equal to tangent of x cubed plus 1. Okay? So ito, hindi na kahit hanapin natin yung formula dito sa unahan, no? Tangent of x. Meron lang kasi tayo yung tangent of x. Pero yung x cube, meron pa tayong hiwalay na formula. So, in this case, gagamit tayo ng chain rule para dito, right? So, subukan natin using the Leibniz notation, no? Sa Leibniz, lagyan natin ayos. Notation, pag sinolve natin yan, syempre magle-let ulit tayo, no? Blue siguro. Let u equal to x cubed plus 1. And ang next step natin is to get the derivative ng u, no? So hanapin natin yung dy du tsaka dy dx. Okay? So yung ating therefore yung ating du dx dito ay equal sa, so kukunin natin yung derivative nito with respect to x, that will become 3x squared plus 0 na to. Diba? So, ganyan na siya. And then, we are now going to get yung ating dy, so yung ating y, no? Therefore, yung ating y will become the tangent of u. right? Kasi pinalitan na natin siya, no? So dapat yata kulay blue. Yan. In this case, sasagutan na natin yung dy du, no? And yung ating dy du will now become equal to yung formula natin ng tangent u, okay? That is uh, secant squared of u, right? Secant squared of u. So ngayon, applying the chain rule, no? Applying the chain rule, that is dy dx, that is yung ating y prime, equal din yan sa dy du times du dx. Okay? So, meron na tayo parehas nito, i-apply na lang natin, no? So, ngayon, yung ating dy dx, pag sinubstitute na natin yan, this will now become dy du, which is secant squared of u, times yung du dx, which is 3x squared. So, palitan natin yung ating u, no? This will become equal to secant squared ng, ano yung u? Ito yun, di ba? X cube, palitan natin ng kulay para mas makita. X cube plus 1, right? X cube plus 1 siya. Times 3x squared. So, i-simplify pa natin ng medyo mas appropriate tignan. So, this will become 3x squared secant squared ng x cube plus 1. Okay? So, ganyan siya, no? Ganyan siya i-solve using the Leibniz notation. Ngayon, subukan naman nating i-solve yan using the Lagrange, no? Lagrange's notation. Okay? So, dito sa Lagrange's notation, wala tayong gagawin kundi i-evaluate yung composite function. Let's say we have y is equal to f of g of x. So, ang sabi, kukunin lang natin yung y prime is equal to f prime ng g of x nang hindi ginagalaw times the g prime of x. So, i-apply lang natin yan. So, if our function is y is equal to tangent of of x cubed plus 1. So, ito yung ating g of x, x cubed plus 1. So, yung ating y prime, equal ngayon sa, ano yung f prime of g of x? Yung f prime daw ng g of x ay secant squared ng x cubed plus 1. And then, i-multiply daw natin ito sa derivative nung nasa loob, no? Itong nasa loob. So, kinuha lang muna natin yung derivative, applying the formula, tapos kukunin natin yung derivative na nasa loob, which is equal to 3x squared. Therefore, yung ating y prime will now be equal to 3x squared times the secant squared ng x cubed plus 1. So, same answers. It depends kung paano nyo siya i-solve using these notations, no? We have the Leibniz notation, then Lagrange's notation. So ako, personally, I use these two notations interchangeably. Mas madalas ginagamit ko yung Lagrange's kasi mabilis lang siyang gamitin, no? Kukunin ko lang muna yung formula ng unang layer ng ng function, tapos yung inner naman, tapos kung meron pang inner yung inner, so tsaka ko kukunin, no? So ganun siya. So let's try to solve another example, ha? Um, Hanap lang muna ako ng isa pang example dito. So ito. Ayan. So, ito mas ma-appreciate nyo yung paggamit ng chain rule. Okay? Uh, Using this example as let's say we have a function y is equal to 3x plus 1 quantity squared. Okay? Regardless kung anong notation gagamitin ninyo, okay lang. No? I will just illustrate how useful yung chain rule. Okay? So in this case, pag-solve natin ito using the regular way, no? Ang una natin ginagawa diyan actually is in-expand natin, di ba? So first natin, first approach natin, i-expand natin siya kasi madali pa siyang i-expand, no? So this will now become 9x squared plus 2 times 1 times 3x plus 1 squared, no? Then, yung itong y na to, magiging equal yan sa 9x squared plus 6x plus 1. Okay? So, pinapahanap sa atin dyan yung y prime. Ano yung y prime? So, in this case, napakadali na neto. Yung ating y prime will now be equal to 9 times yung derivative ng x squared, which is 2x, plus 6 times the derivative ng x, which is 1, di ba? Plus, yung derivative ng 1 ay 0. So, 0 na lang yan. So, i-simplify pa natin, y prime is equal to 18x plus 6. So, ganyan lang siya. No? Pero if we are going to apply yung ating chain rule dito, no? Subukan lang natin i-apply yung chain rule. So, using chain rule, so paano natin gagawin yan? So, let's say that yung ating function sa buo ay naka-squared, no? So, y prime is equal to 2. So, ibababa natin yung power, no? Di ba? So, recall lang natin, ha? So, yung derivative with respect to x ng x to the n ay equal yan sa n times x to the n minus 1. So, in this case, ganun din ang gagawin natin, no? To illustrate, so yung ating x dyan, itong buo, no? So, ang mangyayari dyan, at yung ating y prime will now be equal to 2 times yung buo, 3x plus 1, tapos babawasan natin yung power, that's 2 minus 1, right? Times yung derivative ng nasa loob. Ang derivative ng 3x plus 1 ay 3 plus 0, which is 3 na lang. Therefore, yung ating y prime equal yan sa 6 times 3x plus 1. Right? And in this case, pag in-expand pa natin yan, equal yan sa 18x plus 6. So, equal pa rin silang dalawa. No? Now, ngayon, itong dalawang derivatives na to, equivalent. Hindi yan magiging equal without the additional factor ng 3 dito sa chain rule. Okay? So, napakadali niyang isolve. Tama ba? Kasi nga, ano siya 2 pa lang yung ano niya eh. Madali mong ma-check na tama yung pag-apply mo ng chain rule. Okay? Or paggawa mo pag-expand mo ng function. Pero, paano kung mahirap i-expand yung ating polynomial function, no? Let's say, for example, we are to solve y is equal to x squared plus 5x minus 9 raised to the 11th power. So, in this case, napakahirap na netong i-expand, right? So, imposible na magamit natin yung ating first method na ginawa kanina na expansion. So, hindi yan practical. So, in this case, we will use yung ating chain rule, right? Yung ating chain rule, gagamitin natin yan dito. So, using chain rule, so let's try naman yung isa namang notation, ha? So, let u equals x squared plus 5x minus 9. So, yung mangyari, yung y natin, u to the 11 na lang siya. no? So yung ating du, that du dx will now be equal to 2x plus 5 minus 0. So ito na lang yung du dx natin. Now, balik tayo dito sa formula. So pag in-apply natin yung u na yan, yung ating y will now become equal to u raised to the 11th power. Right? Kasi pinalitan lang natin itong buong expression na yan. And yung value ng ating dy du, no? dy du will now be equal to 11 u raised to the 10th power. Okay? So, using chain rule, y prime, okay, yung ating y prime, equal yan sa dy dx, right? And of course, it is equal to dy du times du dx. Okay? So ito ngayon, hahanapin na lang natin nasa na nga ba yung dy du, nasa na nga ba yung du dx. Okay? So substitute ko lang muna yung ating dy du ay 11 u raised to the 10th power times, pangit ng sulat ko, times itong du dx which is 2x plus 5. Right? And of course, syempre, dapat palitan natin yung u. Kasi para in terms of x na lang yan lahat, yung ating u magiging 11, buray na lang natin to, no? 11 times, palitan natin, x squared, palitan natin na kulay. X squared plus 5x minus 9 raised to the 10th power times 2x plus 5. Okay? So furthermore, if we are going to, kung gusto nyo i-simplify pa yan, pwede naman. Pero dahil ito ay naka-prime factors na sila, yan yung sagot. No? So y prime is equal to this expression or, yeah. So kagandahan dito sa chain rule, napakadali niyang gamitin, no? Imbis na mag-expand tayo, it will save us a lot of time on algebraic manipulation. No? Kasi, ano yan, pag nagsisimplify tayo na nagsisimplify, maaaring yung correct answer, hindi na siya katulad ng form ng sagot mo. Okay? So now, let's try to solve a longer chain. No? Try natin mag-solve ng mas mahirap pa. Yung tatlong application ng chain rule. Okay? So, let's try to solve naman itong function y is equal to the square root, di ba? Square root of sine, square root na may sine pa of x cubed plus 1. So, pinapahanap sa atin dyan yung y prime. Yan. So, with more complicated functions, kailangan na natin i-decompose yung functions na to into 3 or more components. Ibig sabihin, yung composite functions is hindi lang siya dalawang layer. Nagiging tatlo na siya. For instance, itong example na to, meron tayong tatlong layer. Bakit? Una, meron tayong radical. So, yun yung first layer natin. Second, meron tayong trigonometric, no? Tapos meron pa tayong polynomial. So lahat yan kukuha na natin ng derivative. Okay? So finally, meron tayong cubic function na nandun sa loob ng sine. So dito ang key para masagutan natin dito is patience and pagiging organized. Pag organized tayo sa pag-solve ng mga functions or ng derivatives, mas mataas yung chance tama yung sagot natin. Okay? So in this case, kailangan natin ng patience and Okay, so buburahin ko na yan. Tatandaan nyo yan. Burahin ko lang din muna to. Okay. So, i-try natin i-solve itong particular function na to. Medyo challenging siya, pero subukan pa rin natin, ha? So, in this case, we have no choice but to uh, uh, let, ay, sorry. Let u sige. Let u is equal to x cube plus 1. So, ito yung papalitan ko ng u. No? Yun yung papalitan ko ng u. Tapos, pag naging u na yan, ang itsura na ng ating function will be y is equal to the square root of sine of u, right? Sine of u. And then, papalitan ko pa rin itong sine of u, right? Papalitan ko ng p. Siguro gamit tayo ng p. We let p equal to sine of u. Yan. And then, pag pinalitan ko naman ng ano yan, ng p yan, so yung ating y, so dito lagyan natin, y is equal to the square root of sine ng u. So yung ating y magiging the square root of p na lang siya, the square root of p, no? Yan. So ito, mas madali na siyang i-solve, right? Kasi, dinecompose natin yung mga functions into three components. No, we have the y, we have the u, and the p. So now, kailangan lang i-identify natin ano yung components ng chain rule para ma-solve natin ito, no? So in this case, solve muna natin yung dy dt, no? Diyan tayo magagaling. Okay? So in this case, or siguro i-express natin yung chain rule kung paano ito masasolve. Yung chain rule para ma-solve yung mga ganitong functions, dy dx, no? Yan yung ating y prime. It is equal to dy dp. So ito, susolve down natin yan times yung ating dp, no? dp du, okay? Times du dx. So in this case, magka-cancel itong mga to, yung mga nilalagay natin na coefficient, magka-cancel, mga nilalagay natin representation, mawawala sila. So kailangan nating hanapin itong tatlong particular derivatives na to or components na ito, no? So in this case, saan natin mahanap yung dy dp? Dito yan, no? And then yung dp du dito. And yung ating du dx dito naman. Okay? So babalikan natin yan mamaya, no? Sagutan muna natin yung ating du dx. Okay? Okay, yung dy dp muna, no? Yung dy dp, balikan natin mamaya yan, ha? Yung ating dy dp equal yan sa derivative with respect to p ng square root of p. So, ito yan, ito. So, it is equal to, syempre, yung ating formula, 1 over 2 times the square root of p. Right? Yan. Tapos, yung ating susunod natin, dp du naman, dp du, it is equal to the derivative with respect to u ng, ano naman yung gagamitin natin? dp du. Ito, no? Ng ating sine of u. Okay? So, in this case, ang derivative niyan ay equal sa cosine of u, right? Tapos, yung susunod naman, yung ating last is du dx. So this is the derivative with respect to x ng function ng u. Ito yung function ng u, x cubed plus 1. This will now become equal to 3x squared plus 0. So meron na tayong tatlong components ng uh, ating chain rule, right? So ang gagawin na lang natin is to substitute itong mga ito pabalik sa ating chain rule. Okay? And then we will try to substitute yung mga values ng P at saka U, no? So punta tayo dito. So para ma-solve natin 'yan, babalik tayo dito. Yan. Okay? So ang sabi, y prime is equal to dy dx is equal to dy dp times dp over du times du dx. So isa-substitute na lang pala natin itong mga to. Yung una natin, dy dp, ang nakuha natin dyan is 1 over 2 times the square root of p, right? Times yung dp du ay yun naman yung cosine ng u. Times yung du dx, ito naman yung 3x squared. Yan. So, ngayon, ang problema natin dyan, kailangan maging in terms of x yan kasi dy dx yung hinahanap sa atin. Right? So, lahat ng p at saka u, papalitan natin ng mga karapat-dapat na x values. No? So, dito, yung ating p ay 1 over 2. Ano yung value ng p? Sine of u, right? 2 times the square root of sine of u. Right? So, medyo pangit lang yung sulat ko pero ayusin natin ng konti. So, yung ating first ay equal yan sa 1 over 2 times the square root of sine of u. Sine of u. Yan. So, kumbaga ito nililipat ko lang muna. Tapos, yung cosine u naman, palitan na natin ng x. That will become cosine ng x cubed plus 3, plus 1. No? X cubed plus 1 times ng 3x squared. So, ganyan siya, no? So, kung mapapansin natin, meron pa tayong u dito. Palitan din natin yung u. So, this will become y prime equals 1 over 2 times the square root of sine of x cubed plus 1. So, pinalitan ko lang yung u. Times, so, lagay ko lang muna yun. Times the cosine of x cubed plus 1 times 3x squared. No? So, ganyan siya. So, kung gusto nyo pang i-simplify, so ilagay nyo lang sa numerator itong 3x squared cosine cube. So, finally, yung ating y prime equal lang yan sa 3x squared cosine of x cubed plus 1 all over 2 times the square root of sine of x cubed plus 1. Okay? So, ganyan ang pag-apply ng chain rule kapag marami na yung ating functions or yung composite functions natin, nagiging 3, 4. So, ang kagandahan sa calculus with the continual advances sa computer technology, yung mga implicit functions, yan ang may di-discuss natin later. pwede kasi sila ma-program into, let's say, advanced drawing and design software. Yun yung ginagamitan natin ng mga ng mga ganitong application ng chain rule, no? So, yan. Ngayon, balikan natin yung ating mga formula, no? Kanina, we discussed yung formulas natin. Yan. Ito yung formulas natin, no? Yan. Ngayon, we will apply yung yung paggamit ng chain rule dito sa mga functions na ito. Okay? So, ang sabi, sa general power formula muna, no? In general power formula, ang sabi dyan, if we have y is, di ba meron tayong y is equal to x to the n, yung ating y prime, equal yan sa n times x to the n minus 1. Now, if we have a function of u of x, right? Let's say we have a function u of x, and meron tayong function ng y. Let's say a function of u is, sample lang u is equal to a function of x. Lagyan natin f of x. Ganyan. Then, another function ng y, let's say y is equal to u to the n. No? Itong u is a function of x, ha? Okay. So, ang sabi, yung ating dy with respect to u is equal to n times u to the n minus 1 times du dx. Okay? So, napaka-importante nito itong du dx na yan. Kasi, kinukuha natin yung derivative nung nasa loob pa ng u. Dito sa ating unang formula, yung x to the n, wala tayong ginagamitan ng du dx. So, ngayon, yung ating general formula ng power formula is similar to this one, no? I will rewrite yung ating general formula. Saan ba maganda? Dito na lang siguro, no? Yung ating, delete ko na lang siguro lahat. Sa constant, of course, the derivative ng any constant with respect to x ay, of course, 0 yan, no? And then, yung derivative ng sum at saka ng product, so yung sum muna, no? Derivative with respect to x ng u plus v. So, ganun pa rin naman yung principle na yan. Du with respect to x plus dv with respect to x. So, yung product ay ganun pa rin naman, no? So, derivative with respect to x ng product, uv. So, yung u natin tsaka v ay functions, ha? Functions of x. Equal ngayon yan sa first function, that is u, times the derivative of the second function with respect to x plus the second function times the derivative of u, first function with respect to x. And then yung ating quotient, no? The derivative with respect to x ng quotient ng dalawang function equal yan sa denominator times the derivative of the numerator with respect to x plus the numerator times the derivative of the denominator with respect to x all over v squared. Okay. At ito na, yung ating general power formula. The derivative with respect to x ng any function u, no, raised to n, hindi na siya x lang, no? It is equal to n times u to the n minus 1 times the derivative of u with respect to x. Okay? So, tatandaan natin yan. Ibig sabihin, kukunin muna natin yung nu to the n minus 1, tapos kukunin pa natin yung derivative ng mismong function. Okay? So, another one, is yung ating derivative ng merong radical, no? Ng square root of u. Equal din yan sa 1 over 2 times the square root of u times du dx. Yan. So, palagi natin kukuhanan yung du dx, yung derivative nung nasa loob. Okay? So, again, yung ano naman, yung mga trigonometric naman. Let's have the derivative with respect to x ng sine of u. Ngayon, ito naman ay equal sa cosine of u times the derivative of u with respect to x. So, kukunin muna natin yung cosine of u, tapos kukunin pa natin yung derivative nung nasa u. Then, yung derivative with respect to x ng cosine of u, equal yan sa negative sine of u times du dx. Okay? Sa tangent naman, ganun din. No? Lahat naman ito ay pare-parehas. Tangent of u, it is equal to secant squared of u times du dx. So lahat ito yung mga in-apply natin kanina. No? So cotangent naman, cotangent of u, ang derivative niyan ay equal sa negative cosecant squared of u times du dx. Tapos yung secant naman siguro, derivative with respect to x ng secant of u ay equal yan sa secant u times tangent u times du dx. Lastly, yung derivative with respect to x ng cosecant u ay equal naman sa negative cosecant u times cotangent of u times pa natin sa du dx. Okay? So, ganyan siya. Lahat ngayon ng ating isa-solve na mga functions, palagi nga applyan ng chain rule or ng mga ganitong formula. Okay? So, para mas maintindihan nyo pa, I will give some practice exercises for you to apply yung inyong natutunan dito sa chain rule. Expect na marami yung longer chain na i-solve ninyo. Apply natin yung Leibniz notation tsaka yung Lagrange notation, and then let's try kung saan kayo komportableng gawin, and I expect na magagawa nyo to parehas. Okay? So, with that, I would like to end this presentation. Maraming salamat sa pakikinig at see you on the next lesson on implicit differentiation. Okay? Maraming salamat at stay safe.